Pythagoras' theorem, finding the hypotenuse. Our first use of Pythagoras' theorem is finding the longest side, the hypotenuse. Anytime we have any problem that has a formula associated with it, we write the formula to start off with. C squared equals A squared plus B squared. So just, if you need the reminder, write the formula. Then, of course, you substitute in known values. Substitute known values. So I know the two shorter sides. That's 9.5, which I have to square, because it's A squared, and 7 squared. Remember, our equal signs line up down the page. And we evaluate that. 9.5 squared plus 7 squared, 139.25. Now, if you take a moment to look at this triangle, it's quite obvious that this can't be 140 centimeters, or meters, I'm sorry. And the reason is that what we've found there is c squared. We've found the square on the hypotenuse. This shape out here, imaginary. What we need is just c, the hypotenuse. So to go from c squared to c, we find the square root. So you remember when I had a square out here that was 25 centimeters squared, I found the square root of that to discover that that length was 5. So c is the square root of 139.25. So our second step, or our third step, is to solve, and remember we need to use the square root. And then the square root of 139.25, we'd always, if asked, round, and that is 11.8. One decimal place makes sense there. There's people talking out there in the corridor, very annoying. So, when you do this, formula, working, answer with units, you must remember your square root. There is an alternative version of the formula, which is c equals the square root of a squared plus b squared. You can see how this works. You're welcome to use this if you prefer it. It's a perfectly acceptable version of the formula. This one will work for all problems anywhere to do with Pythagoras. Sometimes some of the trickier problems you don't actually want it in its rearranged form. You're better off learning to always start with this. But this is acceptable for basic finding the hypotenuse. We might have the question where we're asked to find c as an exact value. So I'll just start solving for c and then show you what I mean. C squared equals a squared plus b squared. Write our formula, substitute our values. 2 squared is 4 plus 5 squared is 25. So c squared is 29. Notice that when I've finished finding c squared, I must write c squared here. And now I'm going to change to finding c, so I must make that change. I need the square root of 29. And when it asks for an exact value, it's saying stop at this step. Because if I evaluated that, square root of 29, 5.385, 164, etc., etc., I would have to round to 1 or 2 or 3 decimal places if I evaluated it, and that would lose me accuracy, as I did up here. What you do is leave it in what's called surd form. Now this is only left as a square root, as a surd, if it is in fact going to end up as an irrational number that keeps going forever and ever. If I'd come out with c equals, or c squared equals 25, then c would be the square root of 25, and I can give an exact value for that. That's 5. The square root of 25 is not a surd. The definition of a surd is an irrational number in the form of a root. Irrational numbers, the decimal part keeps on going forever and ever and ever. They're not whole numbers. They're not exact values when they're given as a number. So if you can give an exact answer when you evaluate it, you do that. So if this had turned out to be 5, great, we go to c equals 5. If the square root came out as exactly 2.5, we'd say, right, good, c equals 2.5. But if it comes out as something that you would have to round and cut off, then an exact value is given in the square root form. So that is how to use Pythagoras' theorem to find the hypotenuse, and a bit of an introduction to exact values. It's worth noting that this would be very useful if I wanted to use this in later calculations. So if I'd been asked to find this and then had to use this answer to do some more calculations, it's a very good idea to use the exact value rather than a rounded value, because using a rounded value introduces inaccuracy into my working.